Today I want to discuss with the linked list concept. Before going to linked list, in the classroom, already I discussed what is the limitation of array list. Array list is internally using dynamic array, and in the array list, if we want to insert or delete an element in the middle or in the first, then it is always a tough process because all the elements will be shifted, relocated. So the time complexity to insert or delete an element in the array list in the middle or in the beginning, not in the last, in the middle or in the beginning would be big O of n because n number of elements will be relocated. So I already discussed this limitation of array list in the classroom. Today my intention is to give you the idea of linked list. So what is the linked list? Why linked list? How it is better than array list? And in what condition we should use linked list, whether we should use linked list for searching operation or whether we should use linked list for insertion or deletion of any element in the middle or in the beginning. Look, in array list also, if you want to insert an element in the last position, then there is no problem. But inserting or deleting an element in the middle or in the beginning is a what provides a big time complexity. So first, in this video, just I will give you the idea of what is linked list, the complete introduction of linked list, how many types of linked list, how it is working, and then in the next video, I will give you the practical exposure. So let's start. What is linked list? So guys, as you can see, the name is giving what linked list. It is the implemented class of list interface which is available from 1.2 version that we have already discussed in the classroom. Now, basically, a linked list is a what? Linear or sequential data structure. So the first point, linked list is linear or sequential data structure in which elements are stored in a non-contiguous memory location. So this is very important that elements will be stored in a non-contiguous memory location. So in array, in dynamic array, and in array list, what happens? Elements are stored in a sequential order. But here, the elements are stored in a non-contiguous memory location. So arrays, elements are stored in a contiguous memory location. That's why we are getting the cache facility. Because we know after this, the next element address, all the next element address in a sequential order. But here, it is not in a sequential order. It is in a non-contiguous memory location. So one element address may be 1000, another element address may be 1800, another element address may be what 3000, like that. Not in a contiguous memory location. This is very important. Now, each element, each element represents node. Node is an inner class. So when I will show you the practical, then I will tell you that node is basically an inner class which is defined inside the linked list plus. So each element represents node. Each element. Now here, each element represents node. So basically this node is containing what? Let's say if I talk about one node, basically this node is containing what? This node is containing item and this node is containing address of next node if it is a singly linked list. If it is a doubly linked list, then here you have what? Address of previous node. If it is a doubly linked list. If it is a singly linked list, this part will not be there. Only item and address of next node. But if it is a doubly linked list, then here you have an address of previous node as well as address of next node. Now, if you compare this linked list with our array list, so array list stores the element in a contiguous memory location and it is containing what? It is containing only the element. Let's say in array list, if I want to store five elements, five integer objects, then integer is taking 4 bytes of memory. So 5 into 4 is equal to 20 bytes of memory will be allocated, guys. But in linked list, the elements are not stored in an integer format or any other format. In linked list, the elements are stored in a node format, node class format. That means it will not hold only the item, it will also hold the address of next node in case of singly linked list and address of previous node in case of doubly linked list. So we need to focus more that in comparison to array list in the linked list at the time of storage, we are not only holding the item, we are holding the addresses also. Okay, that we will see. Each node is connected with another node to form a linked list. Now, this linkage facility provides us provides us to insert or delete an element in the linked list in the linked list in an efficient manner. In an efficient manner. Okay. So this linkage facility provides us to insert or delete an element in the linked list in an efficient manner. Okay. You can also say it is a collection of node. Now, what is node? I'm telling you. Collection of node. Okay. So basically, this is the basic idea of linked list. Now, types of linked list. So linked list are of three types. So what are those three types? Linked list are of three types. Number one, singly linked list. Sir, what is singly linked list? Sir, singly linked list means what? It will move in only one direction. We can move in only one direction. When I will teach you hash map, then you will get the idea how hash map, when hash call is an encounter, then how this singly linked list will help us. So this is what singly linked list which can move in only one direction. Doubly linked list. Doubly linked list can move in both the direction. We can move in both the direction. Okay. Then the one more is there. Actually, we are not using in Java, but circular linked list. Circular linked list means it will create a circular form of linked list where the last node will point to the first node. Here, last node. Generally, what happens in singly linked list or doubly linked list, your last node is pointing to null. Your last node is pointing to null, which is known as what? Which is known as what? Tail node, head node, and tail node. First node is head node, last node is tail node. So tail node is pointing to null. Tail node is pointing to null in case of singly linked list or doubly linked list. But in case of circular linked list, what will happen? Your last node will not point to null. Your last node will point to first node. Here, last node will point to first node. Then only it will create circular linked list now. Yes. Okay. So if I simply draw one diagram for singly linked list and doubly linked list and circular linked list, let's say singly linked list. In singly linked list, what will happen? As I told you, you have a node in singly linked list which can move in one direction only. So you have a node. This node is containing what? This node is containing two things. First, it will contain item, and then it will contain what? It will contain address of next node. ANN stands for address of next node. And now this is a node. Please try to take care that linked list stores everything in the form of node. But our array list stores the object directly. Here we have what? Item and address of next node. Here we have item and address of next node. This is what? This is your node. You can say it is a head node. When I will show you the practical, then you will get more idea. This is what your head node you can say. Okay. Then when you will add one more element in the linked list, then what will happen? One more node will be created like this. When you add one more element, then one more node will be created like this. Here, the important thing is what? You can move in only one direction. That means you can move from this node to this node like this. You cannot go back. You cannot go back. You can move like this, one node to next node. That's why that is the reason it is just holding the address of what? It is just holding the address of next node. It is holding the address of this node. It is holding the address of next node. Okay. Here also it will hold the address of next node. This is your what? This is your tail node. This is your head node, tail node. This is what how singly linked list is working. It will move in one direction only. Now, if I talk about doubly linked list, In doubly linked list, as I told you, we have what? We have address of previous node, item, and address of next node. And our linked list is implemented by doubly linked list. Whatever the linked list we will learn here, that is implemented by doubly linked list. And this doubly linked list is providing the facility to easily insert or delete the element from the middle of the list, from the beginning of the list. So here what will happen in comparison to singly linked list, it will contain three things: address of previous node, item, item is your actual element, and then address of next node. Address of previous node, item, address of next node. This is your doubly linked list. Why doubly linked list? Because it can move in both the direction. You can store the address of next node. You can also store the address of previous node. So here this arrow will not move in only one direction. It can move in both the direction. That means it can move to the next node, and from here it can also move to the previous node. So this is going to hold the address of this node, but this is going to hold the address of previous node. That is the beauty of linked list. Okay, now? Yes. So this is what? This is your doubly linked list. Can move in both the direction. What about circular linked list? Look, now circular linked list again comes in two flavors. Let me write first. Circular linked list. Circular linked list will come, as the name suggests, circular linked list. So circular linked list will again come into what? Two flavors. Circular singly linked list, circular singly linked list, and circular doubly linked list. Okay, circular singly linked list, circular doubly linked list. Here what will happen? Here you have what? You have what? Let's say I'm creating circular doubly linked list. Okay, circular doubly linked list. So if I create circular doubly linked list, so I can copy this one because singly linked list is very easy. So if I create circular doubly linked list like this. So here it is pointing to address of next node. And right now you don't have any node here. So that means this address of next node is null. Please try to understand what I'm trying to say. So this will hold the address of next node. This will hold the address of next node. But right now you don't have any node. Right now you don't have any node. So it will be null. It will be what? Null. But in the circular singly linked list or doubly linked list, in the circular singly linked list, let's suppose this address of previous node is not there, then it is a singly linked list. So in this singly linked list, what will happen? Now this address of next node will not point to null. This address of next node will point to address of first node. Okay, that means here what will happen? It will it will point to address of what? First node. Whatever the address of first node is there, it is going to point. Okay, that's why it is called circular linked list now. And this is going to hold the address of what? Address of what? Your last node. It is not pointing to null. Look, earlier it was pointing to null. Why? Because previously there was no node. But now in the circular doubly linked list, now it will point toward the address of last node. Address of last node. So please try to understand this is what your singly linked list and your doubly linked list. Here, if you want to write only one point, APN is equal to address of previous node. And ANN is equal to address of next node. Right now, let's say here I'm talking right now. Right now you can see it is what? Head node. It is what? Tail node. So head node, tail node. If you come in the doubly linked list, which is our implementation, here also this is what? Head node. This is what? Tail node. Before this head node, if any item is not there, then this address of previous node will point to null. Similarly here, address of next node, no item is there, then it will hold what? It will what? It will refer to null. It will point to null. But in the circular linked list, what will happen? Now same address of next node. Here it will not point to null, it will point to address of first node. Address of first node. And it will point to address of last node. This is what circular doubly linked list. Okay. Okay, so you got the idea how many types of linked list are there. Now, what is the implementation? Here I am giving you a small idea of implementation. Later in the next video, I will give you the complete idea. So let's say here I want to write a small code of what? Linked list. So whenever we are adding the element, how it is actually working. So public class linked list, it is taking element type E of item. You know, E means element type. So item is a variable of E type. E is a flexible type. Okay. Then here we have a node class. Now, no, actually node is one inner class. So node first and node last. First means what? This first is nothing but, wait, this first is nothing but address of next node. And this last is nothing but address of previous node. And this is what? Your item, actual value, actual item. So let's say public boolean add. You know, this add method is available in collection interface, and now it is implemented in what? Linked list. Now public boolean add E of item. So whenever you will call add method, you will pass your item. That means you will pass your object element, which will be added in the linked list. So whenever you are calling this add method, whenever we are calling this add method, what happens? Internally, one node class object will be created. One node class object will be created. And as I told you, our linked list is implemented by doubly linked list. Singly linked list we will use in hash map. Here we are using what? We are using what? Doubly linked list. In our list interface, linked list class internally uses doubly linked list. So that means node is equal to new node. This node will be created by using singly linked list or doubly linked list? Doubly linked list. Doubly linked list means what? Last. Last means address of previous node, comma item, comma first. First means what? Address of next node, like this. So every time we will call this add method, internally one node class object will be created. This node class object will contain three things. This last is representing what? This last is representing address of previous node, and this first is representing address of next node, and this item is representing your actual object which you want to add in the linked list. So this is what? Address of previous node, and this is what? Address of next node. Okay. So if I show one diagram, just show one diagram only, how it is working diagrammatically, how it is very easy to add the element in the what linked list, and then definitely after this diagram, we will see the implementation, how actually it is implemented by programmatically. So let's say here linked list object list is equal to new linked list. List dot add linked list class is not implementing random access interface like ArrayList and vector, but linked list class implements DQ. DQ came in 1.6 version, which is extending from Q interface. Q interface is available from 1.5 version. So that means linked list supports the methods of DQ. Like one method is there, add first, add last. Few methods are there. Okay. So it is supporting. When we will learn linked list in the classroom, I will give you more detail. So it is supporting the method of DQ also. DQ is an interface which came in 1.6 and extending from Q interface. Q interface itself came in 1.5 version. So I am taking linked list object type, generic concept. So here list.add 12, list.add, let's say false, list.add, let's say in the first position, I want to insert what? NIT, and list.add first, add first. Let's say here I want to add what? Ravi. So what will happen internally in the memory? What will happen in the internally in the memory? Please look. So whenever you want to add this list.add 12, internally what will happen? One node array object will be created. Once your node array object will be created, this is a doubly linked list. So that means here you have what? Your object 12. Here you have what? Address of next node. Address of, sorry, address of previous node. And here after 12, we have what? Address of next node, like this. So right now, you have inserted only one object, that is 12. That's why your address of previous node will be null. And your address of next node is also what? Null. And this is one node is created. This is one node is created. This is one node is created. This is your one node. Okay. This is your one node is created. And let's say this node is created at what? 800x memory location. 800x memory location. Please remember it is a non-contiguous memory location. Now after that, when you write list.add false, list.add false. So whenever you are writing list.add false, what will happen? One new node will be created. Now this new node will be created. in a different memory location, but in a non-contiguous memory location. So let's say the address is what? The address is 1300x. It's not a sequential memory location. It's a non-contiguous memory location. And here you can see, please look at very carefully that here it will hold the address of previous node. It will hold the address of previous node. So what is the previous node address? The previous node address is what? 800x. What is your item? Your item is what? False. And address of next node. Right now, no node is there. That's why null. And now, once it will connect, these two nodes will be connected with each other. These two nodes are connected with each other. And it is a doubly linked list means what? Both direction. You can move 800 to, sorry, you can move 800 to 1300x memory location. And even you can move 1300x to 800x memory location. Why? Because it is a doubly linked list. So when look, this is holding the previous address is what? 800. Now here it will hold the address of next node. So this null will modify, and now this null will hold the address of next node. So what is the address of next node? The address of next node is what? 1300x. Okay, good. Still, it is pointing to null. Why? Because previously there is no node. Now it is the head node actually. No node is, let's say here one node is added. Then of course it will change. Its address will change. That we will see. Don't worry. So 800x false and null like that. Okay. And now here you do one thing. Here you add one more item. Okay, now list dot add. Let's say I'm adding Hyderabad. So, list dot add Hyderabad. So list dot add Hyderabad. After this false, you are adding list dot add Hyderabad. Then what will happen? Look. So one more node will be created. Now that node will created, and that node will hold the address of previous node. What is the address of previous node? 1300x. What is the item? Hyderabad. What is the address of next node? Null. This is one node object is created. It is a doubly linked list. And assume that this node is created at what? This node is created at 1900x memory location. 1900x memory location. So now what will happen? What will happen? This null will change to 1900x memory location. Non-contiguous memory location. It is holding the address of next node. Okay, good, very good. Like that, we have what we have created. Now, these three nodes are there. These three nodes are there. First node is 12. Second node is what? False. The third node is containing what? Hyderabad. After these three, you are writing list dot add 1 comma NIT. List dot add 1 comma NIT. 1 comma NIT. So now you want to insert NIT, but in NIT you want to insert in the first index. That means NIT will be inserted in between these two nodes. NIT will be inserted in between these two nodes. So what will happen? Look, here also same one node will be created. Let me change the color. This node, because you are inserting in the first index. Okay, so this node, let's say the address of this node is what? The address of this node is what? 1150 address. And now its item is what? Its item is what? NIT, Naresh Institute of Technology. And its previous address is what? Its previous address is 800x. Its previous address is what? 800x. That means this NIT is pointing to this NIT is pointing toward this 800x memory location, and its next address is what? 1300x. 1300x. So what will happen? Like this. Okay. What will happen now? This link will be deleted, and now this is going to hold. Look, let me delete this link. It will be deleted, and now it is going to point. This is going to point the address of this node, and this is going to point what? The address of this node. And again, it is a doubly linked list. Okay. And this 1300x, earlier this node was pointing to 1300x. Now it is pointing to 1150x. And this was pointing to 800x. Previous node address was 800x. Now it will point to 1150x. So what you learn from here, if you look at this diagram, what you learn, if you want to insert an element in the middle of the list, then it is very easy process, because it is not going to reshuffle or relocate all the elements, just like what we have learned in array list. Here, inserting the element is a very easy task, because only two node address will modify. It will not disturb the entire list. And that is the beauty of linked list. That's why linked list is the first choice for insertion or deletion the element in the middle. Okay. Now the last element you can see list.add first Ravi. List.add first Ravi means what? You want to insert Ravi in the first position. So once you want to insert the Ravi in the first position, what will happen? Here also one node will be created. This node previous address is what? Null, because now it is the first node. It is the head node. Earlier this 800x was the head node, and this 1900x is the tail node. But now this Ravi, and now it will point to what? 800x memory location. This node is what? Now head node. In linked list, searching is always starts from head node. That's why linked list is not a good choice for what? For search operation. If you want to search an element in the linked list, then you need to start from the head node. You can start from head node, you can start from tail node, or you can start from what? The closer end. Let's say you want to search this 12, then definitely you cannot start from the what? Tail end. You need to start from the head end. But let's say you want to search this false. At that time, you can start from what? Tail node also. I will tell you in the practical part, you will get more clarity. So let's say this Ravi is created at 150x memory location. So it is pointing its previous address is what? Null. Item is Ravi. It is pointing to 800x memory location. Here one link will be established. It is a doubly linked list. And now what will modify? Only one thing will modify. What? This null will become what? Now it is holding the address of previous node. Address of previous node means what? 150x memory location. Good. So this is your what? Linked list. Basic idea I have given to you diagrammatically. In the next video, I will talk about what? Programmatically, how it is working, how to define the inner class, and all the details. Thank you all of you.